purpose of this video is to give us a brief background on heat and thermal energy. First thing I want to talk about is temperature. So what is temperature? Temperature is the average amount of kinetic energy in a substance. And so what we do, if we want to look at this, let's put 3 containers, and let's actually make them rectangles. So let's put 3 containers here. There's one. Let's make this one a little bit bigger, and then have this one even larger than that. And so let's say this one is 10 milliliters. This contains 10 milliliters. Let's just give it water. Let's put some water in this one, and let's put some water in this one. Let's say this one's 20 milliliters, and let's say this one's 30 milliliters. And let's give each one of them a temperature of 15 degrees Celsius. So let's put 15 degrees, 15 degrees, 15 degrees. So which one obviously has a greater temperature? Well, they're the same. And it doesn't make any difference how much the amount is. Temperature is not based on the size or the amount of the substance or the object. It is based upon the average amount of kinetic energy that's within. If I were to take water out of this one and put it into here, would that change the temperature of either one? If I take some out of here and put it in here, that they would still maintain a temperature of 15 degrees no matter how much water. But if we look at thermal energy, if we take and we look at the amount of thermal energy, so I'm going to go to this one, thermal energy is determined by the amount of mass that an object has. So obviously the more mass, determined by the mass. So the more mass, the more energy it has. And we're talking thermal energy. So this one would actually have more thermal energy than the other two, because it has more mass. It is not based on the temperature, it's just simply based on how much it has. Going back to temperature, we have our temperature scales, and we know these. We have our Fahrenheit scale, we have our Celsius scale, and we have our Kelvin. Our Fahrenheit scale is the one we're familiar with. If I were to tell you it's 32 degrees outside, so let's say it's 32 degrees outside, you know what that means. You understand that. You know that it's going to be cold that day. So you watch the weather, they give you the temperature, it's based on Fahrenheit scale. The Celsius scale is, we're familiar with it in class, but on the Celsius scale, 0 degrees is equal to 32 degrees. So 0 degrees Celsius is 32, and that gets tricky because of the different conversions. If I want to convert these, here are the formulas that I use to convert these two temperatures, one to the other. Kelvin is our SI scale. This is our International System Scale for science. This is the one that's like a meter or a second. It's our international system. Kelvin is a value. It is not measured in degrees. So it is just simply a value. This is where we get our SI, or our absolute value that we'll talk about when we talk about thermodynamics. The conversion is simple. If you have Celsius, you add 273.15. So the increment changes are equal. If Celsius goes up 1 degree, Kelvin goes up 1. You just add 273.15 to it, and we'll talk more about that once again when we get to thermodynamics. But these are our temperature formulas to convert from one to the other. So next thing is, what is heat? Heat is a flow of energy. Based on a difference in temperature. And if you do not have a difference in temperature, you do not have heat. And that's a misconception. If you take your chair that you're sitting in right now, if you're sitting, does that chair contain heat? And the answer is no, it doesn't. Matter does not contain heat. Matter contains energy. Heat is that flow of energy as it travels based on the due to a difference in temperature. So if I have an object that is 70 degrees and I put it with an object that is 20 degrees, heat will flow. Now, which direction? Well, heat always flows from a hot to a cold substance. And when we say hot to cold, we're talking temperature. It flows from hot to cold, so it will flow in this direction. In other words, this will lose heat energy, this will gain heat energy. The greater the temperature difference, the more that works, obviously. So if I go from 70 degrees to 69 degrees, I don't have much temperature difference, so therefore not much heat is going to flow. So don't get that confused with other things. Also, on a cold winter's day, if you stand at the door, the cold air is not necessarily coming in. I'm not talking about wind, I'm just talking about cold. The cold doesn't come in, the heat actually goes out because we go from a higher temperature to a lower temperature as heat travels. And this is determined by the amount of the average kinetic energy within that substance and the flow. And we're going to be doing things with this a little bit later. Once again, this is just simple background information. So the next thing is thermal equilibrium. So once again let's go to our let's get a couple of containers here. Well, let's just take this one container and let's put water in it. Let's say the water is 20 degrees Celsius or 20 degrees, and let's say the surrounding air around it is 70 degrees. Well, what's going to happen? These two, will they stay the same temperature? And the answer is no. This will eventually equal with this. This will decrease, this will increase, and you will have what is called thermal equilibrium, in which they share a final temperature. We'll get into the calculations of that soon. But we will share the calculator, we will do the calculations on this, but they will share a final temperature. So if let's make a better example here. Let's say I drop an ice cube that's at 0 degrees Celsius. I drop that in here. Well, what's going to happen? Will the ice stay at 0 degrees? Will the water stay at 20? Well, you already know the answer to that. They will balance out eventually. They will share a final common temperature. That is known as thermal equilibrium. At thermal equilibrium, heat does not flow. So the next thing, let's answer a couple questions. Which would have a greater temperature, a cup of boiling water or a large pot of boiling water? Give you just a second to get an answer. Well, based on what we've already talked about, they would have the same temperature. If we give these a temperature, so let's use our Celsius scale. Boiling water boils at 100 degrees Celsius. So it doesn't matter how much. They both have the same temperature because they're both boiling at the same. So once again, temperature is not based on the amount. But which would have more thermal energy? The large pot, because of the greater mass. Remember, the amount of thermal energy is determined by the amount of mass. So let's say, let me do one more question with you. Let's say I have an ice cube at 0 degrees Celsius. We'll just keep it at 0 degrees Celsius. Let's have an ice cube at 0 degrees Celsius. Which has more thermal energy? An ice cube at 0 degrees Celsius, or let's go outside, let's say all outdoors, and let's say the air temperature outside is 20 degrees below zero. Let's say we're up north somewhere. It's 20 degrees below zero. Which has more thermal energy? Well, the answer is the outdoors, because there's so much more mass outdoors than there is in that block of ice. Therefore, the outdoors would have more thermal energy to it. Internal energy is the total amount of energy. I'm not going to spend much time on this. I just wanted to let you know it's the total amount of energy in a substance. And the last thing I want to do are the units. We have two basic units. We have a joule. Since this is energy, we're having a joule. And we know that if we take a joule, the number we're going to give it is 4.186 joules per gram degree Celsius. And that is equal to 1 calorie. And that is our other unit of heat, is the calorie, or another unit of heat. So we have joules and we have calories. The other number is 4,186, and that is joules per kilogram degree Celsius, and that is equal to 1,000 calories. So these are our conversion factors, and we'll talk more about what this means. This is actually getting into specific heat, and we'll talk more about that in another unit. But our 1,000 calories, this is our dietary calorie. So if you're ever counting calories, this is our dietary calorie. So if you see a food label, let's say you have a food label that in substance has 500 calories to it. Let's say it says it has 500 calories. Well, that is actually 500 times 1,000. So that's 500,000 of these calories that you're actually looking at, because a dietary calorie is based on 1,000 calories. So this is some basic information that I wanted you to have that's not necessarily explained in some of the other videos.